Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to simplify rational expressions. What is a rational expression, you may ask? Well, a rational expression is the quotient of two polynomials. Remember that quotient means division. It's a fraction. Think of a rational expression as ratios, fractions, or quotients of polynomials. This right here is what's called a rational expression because you have polynomials both in the numerator and the denominator. A rational expression is in simplest form when the numerator and the denominator are polynomials that have no common divisors. In other words, once they're completely simplified like a regular fraction reduced to lowest terms. Let's take a look at what I mean. Here you have some examples of rational expressions in simplest form. X plus 1 divided by x minus 1, you can't cancel that any further. Now, you may say, Morrow, can't you get rid of the x and the x? No. Let's go ahead and learn this right now. You can never cancel out individual pieces of polynomials. Remember that. You can never cancel out individual pieces of polynomials, okay? In order to cancel something out, you have to have a complete, exact polynomial, both in the numerator and the denominator. Number two, or the second example, this is in simplest form. Let's prove it though. Let's go ahead and factor this numerator. What times what is 2, but when added together is 3. This would be x plus 2 times x plus 1 over x plus 3. None of these can cancel because none of these binomials are identical. So this is why both of these are in simplest form. Let's look at what not in simplest form looks like. I have the monomial x divided by x squared. Remember that when you divide the same base, you subtract the exponents. So that would equal x to the negative 1, which would equal 1 over x. That's why that is not simplified. The next example, see how I have this complete x minus 3 binomial divided by this x minus 3 binomial? Any polynomial divided by itself will always equal 1. So this would go ahead and work out to be 3. And then if we go ahead and factor the numerator and the denominator, I'm going to get x minus 3 times x plus 2. And here in the denominator, I'm going to get x plus 2 and times x minus 1. If you notice, the exact polynomials x plus 2 can cancel out to 1, and I'm now left with a simplified polynomial of x minus 3 over x minus 1. So, if you simplify a rational expression by dividing or canceling out okay, the common factors in both the numerator and the denominator. Factoring the numerator and the denominator first will help you find the common factors and divisors easily. So please always factor first before you try to simplify. And again, remember, you can't eliminate individual pieces or individual terms of polynomials. All right. Let's get to this. Let's simplify each. Okay, well, 24 divided by negative 6, that's going to go ahead and equal us a nice negative 4. X cubed divided by x squared, you keep the base, subtract the exponents, x to the first power. And y squared divided by y cubed is y to the negative 1 power. But then when simplified is negative 4x over y, because you always want positive integers. B, let's go ahead and factor the numerator and the denominator. We've got x plus 4 times x minus 2 over x minus 3 times x minus 2. I have an identical binomial of x minus 2 in the numerator and denominator. That cancels out to be 1. And my simplified answer is x plus 4 over x minus 3. Next, Let's go ahead and factor the numerator here. We've got x plus 2 times x plus 5 divided by x minus 5 times x plus 2. Please notice that the x plus 2 and the x plus 2 are the identical binomials that cancel out, and my simplified answer is x plus 5 over x minus 5. Friendly reminder, no, you cannot eliminate those x's. No, you cannot eliminate those 5s. Why? Because you would be taking out or eliminating individual terms from polynomials, and that's a no-no. Next, first let's go ahead and factor out a negative 4 from this numerator, giving me an x minus 3 and then this is a difference of squares, so this is going to be x plus 3, x minus 3. Please notice that the identical x minus 3 binomial is in the numerator and denominator, canceling out to 1. So I'm left with my simplified rational expression of negative 4 over x plus 3. All right. Now, sometimes you will have to find what's called the domain of the rational function, okay, which defines all the valid x values of the function. Please remember that denominators can't equal zeros. You can never have a 0 in the denominator. That is called undefined. Therefore, when asked to find the domain or determine the values which make or makes the rational expression undefined, simply factor the denominator and set it not equal to 0. Why are we setting it not equal to 0? Because the denominator cannot equal 0. The solutions that you find are what's called the restricted values of x and will help you determine the domain of the function. So let's get right to it. When asked to simplify and determine the values for which a rational expression is undefined, in other words, the restricted values or domain, always follow these steps, please. Number 1, factor both the numerator and the denominator. Number 2, find the values for which the rational expression is undefined, in other words, the restricted values or your domain. And last but not least, now, once it's simplified, once it's completely factored and you found your restrictions, now you can simplify the rational expression last. For example, okay, first things first, we're going to first factor the numerator and the denominator. So I'm going to factor out a 7x, leaving me with an x plus 2 divided by 49x. And now I factored both the numerator and the denominator. That's step 1. Step 2, find the restrictions. So for my restrictions, I'm going to set the denominator not equal to 0. And when I solve, that means that x can be any value on earth except for 0. Any value on earth except for 0. And then, now, step 3, we can go ahead and, we can go ahead and simplify. So 7 goes into 7 one time, it goes into 49 7 times. X divided by x cancels out to be 1, and my simplified answer is x plus 2 over 7. And my restricted values are that x cannot equal 0. X can equal anything else except for 0. And that's your domain as well. Next, step 1, let's factor the numerator and the denominator. So this is 5 over x minus 3 times x plus 1. Okay, step 2, let's go ahead and determine the restrictions, find the undefined values. So I'm going to set x minus 3 not equal to 0, and I'm going to set x plus 1 not equal to 0. So therefore, when I solve, X cannot equal 3 or negative 1. Those are my restrictions. X can be anything else on earth except for 3 and negative 1. And now step 3, I simplify, but there's nothing to simplify here, so my final simplified answer is simply 5 over x minus 3 times x plus 1. Done. Next, okay, let's factor. Remember that when we have 4 terms, we're going to factor by grouping. So we're going to group this. We're going to factor out a y squared here, leaving me with a y plus 1. I can factor out a negative 3 here, leaving me with a y plus 1. I factor out my common binomial of y plus 1. And then my leftovers are, of course, y squared minus 3 over what times what is negative 2, but when added together is negative 1. 1 minus 2 times y plus 1. Okay, step 2, that's factoring, that's step 1. Step 2, let's go ahead and get my restrictions. My restrictions would be that y minus 2 cannot equal 0 and y plus 1 cannot equal 0. So therefore y cannot equal 2 or negative 1. And now that I have my restrictions, step 3, I can simplify. So now I have here in step 3, y plus 1 times y squared minus 3 over y minus 2 times y plus 1. The y plus 1's cancel, and my answer is y squared minus 3 over y minus 2, fully simplified, and we found our restrictions as well. Last but not least, factor both the numerator and the denominator. Nothing much to factor here in either one of these. So step 2, let's find my restrictions. My restrictions will be that x plus 3 cannot equal 0. So therefore, x cannot equal negative 3. So the domain is that x can be anything it wants except for negative 3. And there's nothing to simplify, so we are completely done. Simplified form, we got our restrictions, and there you have it. Thank you so very much, and I hope you learned a lot. We just learned today how to simplify rational expressions and find restricted and or undefined values or the domain. Hope you learned a lot. Come back anytime. Take care now. Bye-bye.